Alright, this is going to be another video describing basic algebraic manipulation. I'm going to do it a little different from the other video. I'm going to do a backwards problem so you can see how these problems are built, and then I'll solve that problem so you can see how it relates. So let's take x equals 3. Okay, so we all know that x equals 3. Now let's say that I wanted to make x a little bit more hidden. What I'm going to do is I'm going to add 3 to each side. So as you can see, x is not as apparent anymore. X still equals 3 if we solve the problem, but it's not as apparent. It's not readily recognizable that x does equal, in fact, 3. But we can do this even more. We can say, well, I like that, but it'd be even better if we could divide that by 2 then. Alright, so we're going to divide by 2 on each side. Now that's interesting. X plus 3 divided by 2 equals 3. Now we see that it has an equals 3, but the x is even more complicated. This is what is happening to your equations that you see. Your equations that you see are the other end of this. If you see, we're building an equation that someone will have to solve. Now, another way that I would say is I would say, well, now I like that, but I want to multiply it by 5. Because why not? So I want to multiply each side by 5. So now it's 5 parenthesis x plus 3 over 2 and heck equals 15. And heck, I think I could do even better, so I'm going to minus a 2. So now I get 5 plus 3 over 2 minus 2 equals 13. All right. So now that we built that equation, we've said that that's what my equation is going to be. I'm going to take this and I'm going to solve this equation right next to it, right next to how I built it. And you'll see it come together. So this equation is going to be like this. So we're going to do the opposite steps to get us back up to x equals 3. So what was the step we did over here? Well, we subtracted 2, which means that we have to do the opposite step to that, so we're going to add 2. So we're going to add 2 to each side. Now we get 5x plus 3 over 2. We add 2, that cancels out and gives us 15. And now we say, well, now we're going to divide by 3, or divide by 5 to each side. Those cancel out. Now we're back to this point, x plus 3 over 2 equals 3. We're close. We're getting closer to what our original was, right? If you can see there, it's similar to what our original problem was. Now we need to multiply each side by 2 because we divided over here, if that makes any sense. We divided this one by 2. Over here we multiplied by 5, so we divided by 5 because that was the opposite. And this one we're going to multiply by 2 because that's the opposite reaction. So x plus 3 equals 6. Now we're going to minus 3. X equals 3. Now that's how you would build a problem and then how you would solve said problem. But this looks really complicated. If we were just to give you a problem, 5x plus 3 over 2. If you were just to see this problem, you wouldn't know what steps they did to get there. And that's where we have to use our opposite of the order of operations. And the steps they took to get there was this. Makes more sense if this is over here. Because that minus is 2 right there. There we go. They use the order of operations to create it. Now we are using the order of operations to undo it. But we got to do it backwards. So algebra is the process of solving an equation for an unknown variable. We use it in real life when we don't know something. Say, a common problem that we use it for is when we have to carpet a house. We don't know what the area is, so that's our unknown, but we have a formula to solve for it. Formulas are just fancy things, fancy equations that solve for a specific unknown. Algebra helps us to turn any problem that we don't know into an equation that we can solve for. Whether you need to build fencing in your yard, or you need to find out how much food you need to buy for a party, depending on how much everyone's going to eat. Variables are just unknown numbers. They help us to solve equations that we may otherwise not be able to solve because we don't know all the numbers. Knowing that this is how they're made, that they start with an x equals something and then they change it, make it look all complicated, then we can come back and make it to, so we start here and we can come back and make it here. Right? We proved that x equals 3 in both occasions. We proved that when we solve this and we plug in a 3 for x, it equals 13, and I'll show you what I mean by that. So there's a way we can check our answer in algebra. So we got x equals 3 as an answer. And we know that's the answer because we built the equation. But I'm going to show you how you'll know if it is the true answer or not. If you're unsure of your answer, you can always plug it back in and solve the equation. If it equals 13, then we know we got it right. And I'll show you what I mean. So we take and we plug in wherever x is, we plug in 3. Oops, that's too long of a parenthesis. So I put it in parentheses to show you which 3 was replaced by the x. Alright, so now we do 3 plus 3, so 3 plus 3. That gives us 6 over 2 times 5 minus 2 equals 13. Now 6 over 2, that's just 3. And 3 times 5 is 15. Minus 2 is 13. Okay, now we say, okay, well that is true. 15 minus 2 equals 13, so 13 equals 13. That works if you plug a 3 in. That's why, because we know 3 is the solution. What happens if we plug a 2 in? What happens then? Do we get 13? Let's find out. So if we plug in an answer, let's do 1. So if we plug in the number 1, because 1 was not a solution that we got, we only got 3 as a solution. All right. So now we're plugging in 1 for our x instead of x equals 3, and we'll see if it equals 13. We'll see if 1 is a solution. So 1 plus 3 is 4 over 2, and that's times 5 minus 2. This is just 2. So 5 times 2 is 10, minus 2 is 13. So 8 equals 13. That's not true. 8 never equals 13. This is the symbol for does not equal. It's an equal sign with a line through it. So 8 never equals 13. If you plug in a number that's not the solution, you will not get 13 equals 13. There's no way. Because x only equals 3. We showed that with our math. There's no x equals 1, x equals 2. X only equals 3. So why is it important? Why is it important that we know what x equals? X could be anything. Can't we just plug a number in? Well, no. Because there's only one solution that makes this equation true. And that's 3. And that's important when we're doing things like rocket science. In rocket science, sometimes they don't know what speed to fire something at to get it through the atmosphere. But there's only one speed that actually gets it through the atmosphere. If you do it too short, it won't make it through the atmosphere and it'll crash land down to Earth. If you make it too fast, it'll burn up as it goes through. There's only one speed which will allow it to pass through the atmosphere and make it into space. Or, in an example that's more towards our lives, if we want to know how much butter to add to a cookie recipe, there's only one amount of butter that will work. We can't plug into a recipe and say if it says it wants half a cup of butter, we can't put a cup of butter in and assume that the recipe is going to come out the same. We have to put in what we're expecting to get out. In this case, with algebra, 3 is the answer. Because it is the only answer that gives us 13 when we solve the equation down. And so algebra is useful in real life when we need to find answers to problems. We use it in computer programming. We use it in cooking. We use it in building construction. We use it in accounting, in business practices. Algebra is used in more things than we think, and some of it's intuitive. We ask ourselves, if I need to make this much, how much of this will I need to make? And we usually just can find the answer. It's like if I need to make 12 dozen cookies, which is a lot of cookies, and my recipe makes 2 dozen, how many times do I have to duplicate the recipe? Well, the answer is 6. But we use algebra like that all our lives. Sometimes we just don't know. Now, algebra can get really complicated when we're doing really complex problems like sending a rocket to space. But it can get really easy when we're doing problems like cooking. But the reason we have algebra is because it's an intuitive way to solve problems. It's a way to use numbers to solve humans' problems. Because we as humans have a lot of problems. And numbers solve only a fraction of our problems. They don't even solve all of our problems. But we can use numbers to help us understand how some problems work. And that is why algebra is so important. And I hope this video helps you understand how to use algebra backwards. And how these problems were made, and why there's only one solution. And that is the end of another video of part 2 of explaining basic algebra.